Ishika, start.
Okay, sir. Welcome back, everyone. I now invite Dr. Pankaj Kumar Goswami, who is an associate professor at Tirthankar Mahavir University, Moradabad. He has achieved the BTech, MTech, and a PhD degree in the area of electronics engineering with vast teaching experience of 15 years in reputed organizations. He has more than 30 international publications in reputed peer-reviewed journals including IEEE Explore, Scopus, and SCI Index. He is a potential reviewer for reputed journals, conferences, Index, and Scopus, and Web of Science. His main area of research is machine learning, Internet of Things, wideband antenna designs, cognitive radios, and power quality issues in nonlinear electronic devices. He has organized several national and international conferences, symposia, and webinars. Dr. Goswami has also published several patents in the field of antenna designs, Internet of Things, machine learning based applications under the intellectual property rights of the Government of India. He is an e-educator in the field of machine learning using Python. He is actively associated with NAC SSR preparations at University Interface and visited several times SAARC countries like Nepal, Bhutan, and Seven Sisters for various academic promotional activities. He is a professional member of several national and international bodies. Dr. Goswami has been involved in various educational outreach activities through online sessions on artificial intelligence, machine learning, and smart antenna. So please welcome Dr. Goswami, whose speech title is Artificial Intelligence, a Necessary Attribute of Today's Technology. Over to you, sir.
Thank you very much, Ishika, just introducing me here. Thank you very much. And first of all, I'm highly thankful for the organizer to just organize such a great event. Because nowadays, like this is just only the option to just get the learning because we all are just facing the pandemic situation. And among them, like such kind of activities and activities are definitely creating some sort of a boost to develop more attributes related with your technical areas, your growth, facts related with the various kind of academic activities. So well, it's all in all good. Thank you very much. So let me share my screen, not just taking so much time
पहले
here.
तो लिखा हुआ है रिसर्च पेपर इन पीयर रिव्यूड और यूजीसी लिस्टेड जर्नल्स और उसके बाद क्या सर हाँ 8 पर पेपर और उसके बाद नीचे उसमें लिखा हुआ है सर 1 मिनट रुक जाना प्रतुल अरविंद सर का कॉल आ रहा है जो शाम के स्पीकर है मैं एक बार उनसे बात कर लूँ हाँ सर गुड मॉर्निंग
स्क्रीन विजिबल
गुड मॉर्निंग सर हेलो
Is my screen visible? Let me know please, Ishika.
हेलो हाँ सर गुड मॉर्निंग बढ़िया सर सर आपका 2:30 से है
let me know whether this screen is visible or not.
टीम नहीं गेस्ट के तरीके से भी जो लिंक मैंने भेजी हुई है ना आपको सर मेल गई है आपको 1 मिनट सर अभी
No, sir, it's not visible.
Not visible right now?
Yes, now it's visible, sir.
Now it's visible. Thank you.
Now it came up, sir. Presentation.
Expecting now it is visible properly. And the second thing is like I'm properly audible to all.
Yes, sir.
Sir,
yeah, thank you very much. Just giving two confirmation because right now we are just kind of having online systems. And like we are totally depending on devices. That's more important to first of all check the devices whether they are supporting us nicely or not. So let's begin with the today's discussion. The topic we have just taken as artificial intelligence, a necessary attribute of the today's technology. Yeah, we can understand that everyone is talking
जी
about the
सर,
artificial intelligence, not only talking, but even that we
सर्टिफिकेट
are
सर
using
एआईसीटी पोर्टल से डाउनलोड होगा।
incorporating that particular
हाँ,
artificial
इनका पूरा
intelligence in most of
कंट्रोल
the
वहीं से है
technologies
ना, एआईसीटी
and
हाँ।
the utilities we have in
जी
our
जी।
hand related
वो
with this
अंडर नियम
artificial
ये है कि वो
intelligence. So like
जो है ना कॉलेज से
just
मिलेगा, क्योंकि वो कॉलेज के
everyone
पर
is
अभी
having a
कॉलेज के
use
अकाउंट
of
में
this
पहुंचा नहीं है,
artificial
एक आध दिन में
intelligence,
पहुंच
trying
जाएगा,
to
तो फिर वो जल्दी
incorporate
मिल
in
जाएगा, मतलब टेक्यूब
every
जैसा नहीं
kind
है
of
ये।
a things related with this one. So those who are working in the
ऑनरेनियम
areas of the
कॉलेज से
research,
मिल
they
जाएगा
are also
आपको
looking to
जल्दी ही,
creating
जैसे ही कॉलेज के
artificial
अकाउंट में
intelligence.
पहुंचता
Some
है ना,
people
एक
are
दो दिन में
working in the
कॉलेज के
power
अकाउंट
grid
में आने
sector,
वाला है, तो
making it
जल्दी
smart.
प्रोसेस करेंगे,
So
10-15 दिन
making
में ही।
smart, creating
क्योंकि
like
ये
a
टेक्यूब जैसा
device
नहीं है ना,
more
टेक्यूब
smart,
में
it's
एक्चुअली
somewhat
लंबा
related with the
टाइम वेट
creation of
करना
an
पड़ता है।
intelligence in that. So this is exactly the topic, and that's why the topic is like
हाँ
it is
हाँ,
a
टेक्यूब में तो
necessary
सर लोग
attribute of
जाना
today's
बंद कर गए
technology.
फिर।
It's not like related with like you're
ठीक है सर।
simply working in the domain of the
ओके ओके।
computer science, then you're working and finding out the artificial intelligence are important to just develop the algorithms and like that.
जी
But
सर।
whatever you are doing, whether you are just working in
हाँ
the areas of the electronics, working in the areas of the electrical,
हाँ, तो अब
and
इसका
even
मुझे
you
समझ
just
नहीं आ
have
रहा
a
था कि कैसे
sensor in your hand and try
करना
to
है वो,
find out
जो है
some
ना
sort of the
अभी।
humidity
एक तो
is
मुझे तो एक
around
समझ
you,
में आया कि
then even you are
8%
just
पर
trying to
क्लेम
make
कर
it
ही दूँ,
more smart,
ठीक है।
which is exactly the
और
artificial
बाकी जो
intelligence.
नीचे
That
ऑगमेंट करने
exactly
का
we
है
are
ना,
looking for.
कि अगर
So
विदाउट
that's why
कॉन्टेक्ट
this
वेक्टर है
topic
तो
is
5
basically
नंबर और ऐड कर दूँ,
introducing
मतलब 13 नंबर कर
every
दूँ मैं उसको।
technology has a scope, that every technology has a
ऐसे ही करने दो,
basically a
बाकी
space
जो
where
होगा
this
उसके बाद
artificial
देखेंगे वो।
intelligence can be inserted. So
ठीक है।
let's checking it out. Why
ठीक है
exactly? The most of an important part is here. If suppose we have a certain skill, we are just working on that, and we are trying to incorporate in that. So whether it has some sort of the utility, and the utility is totally depend upon a skill in demand. What kind of a skill is basically looking? If you go for this is a basically the data is taken from the Google Trends, which is giving you perfect information for the last couple of years that
हाँ जी मैम।
people are searching, people are trying to find out, and where they are just putting their interest in that. If they are finding, they are looking for the interest, you
ये
find out that
यूट्यूब
Google
पर
Trends is
मेरी
giving
आवाज़
us
आ
so
रही
much great results in the last
है, एक
couple of
मिनट एक
years
मिनट।
that search related with this artificial intelligence is just getting a great hits on the Google itself. So this is exactly the reason why one should incorporate this AI in everyone's technology, whatever the kind of a technology they are just having, everyone should come up with this. Simply looking for like what kind of interest in the worldwide regions are here. So the countries which are already developed, they are having applications, they are having a utilities along with the AIs are definitely showing a less interest, but the countries where there's a chance of a development are there. The people are working and try to hitting more related with the information on the Google to find out more details, try to learn more about the artificial intelligence. So the everyday's technology and everyone's technology may be converted into the artificially intelligent smart tech. You see here, this is a very interesting result. Like the Zimbabwe is searching its 100% time, and Ethiopia, like country, China is definitely always competing in all the directions. And even if we see here, Pakistan, Nepal, that are as compared to us, they are quite above as compared to the India. So the only 64% like kind of an interest we have in India, even that the Nepal has a 68%. So this is exactly we are lagging behind. And that's why it is important that everyone should have awareness of this one. That artificial intelligence and the making a system smart is more important. And where we are standing right now when we are comparing with the technology which is being used within the world. That's exactly one important aspect. So let's see more about that. How much of interest that definitely, as we are comparing only in India. So again, for the last couple of years, we are having a better insight, getting a more hits, getting a more responses, and obviously now the interest has been increased because of this particular aspect. That interest is just keep on increasing in India. The people are learning, creating, developing, and most important, deploying this particular artificial intelligence algorithms and making more devices smart. So this is basically interest over the India, keeping it more in like Indian regions. We belongs to definitely the different kind of areas of the India and different regions are there. So again, the Andhra is doing so well. The people are just having great interest behind that. And similarly, if you see here, Puducherry, Telangana, Tamil Nadu, Karnataka, Delhi, Kerala, Chandigarh, Maharashtra. So, like if you see here, like all these areas and the different kind of a region in India are incorporating, working on that. So, if you see, if you belongs to any one of the area like that, where you just have a certain kind of interest, you should keep on that what kind of a contrast and competition you are having here. That is exactly important, because where you are lagging, and see, large number of the research areas are there. Different kind of the research is going on. But the most important part is there. Your research is basically needed somewhere or not. Is basically in demand or not. Whether you are in the field of some race or not. See, like we have a race of car and we are just keeping our cycle with us, so that doesn't matter. And suppose that we have a race of a cycle and we are having our own car, that definitely is not going to create a big difference. That's what important part, that where we are and what kind of skills are basically looking for, and where the world is trending towards, because we all belongs to academics, and the academics, definitely there is a requirement of creation of the different kind of entrepreneurs. We are seeking out the different kind of jobs, and until and unless we are just dealing with this skill based knowledge, skill based technologies, then definitely we shall be just having some sort of the sacrifices behind related with the job and development of the growth. So that's why this is all about the interest reason, and this is basically giving a certain cause why one should go for creating their system smart, going to create your system artificially intelligent. That's what exactly. So, like it's a very simple kind of attribute. If you see here that most of the part which is being developed is only because of the human intelligence. So first of all, if we see here, the most important part is what exactly the human intelligence. So we have to develop our brain too compatible to learn of the things, and that's why see here. This is just only the because of that we itself created the so more powerful that we are. The more powerful is human intelligence. Many times you see that you have a Google navigator in your hand. So you're working the Google map and you're just navigating yourself from one point to another point. And sometimes you find that the navigator is giving a certain kind of a path where you just find there is a no road, is a blockage. And at that time, you just come out from your car or your bike or your vehicle, and then you ask to the people exactly whether this particular pathway is here or not. So here, the most important attribute, what I always say, is human intelligence. Human intelligence should always be incorporated in the AI to make it AI more smart. So this is exactly the motive of this one. If you see here the development, so this development is just showing that we grown up first and then we create it. Most important part is still this process of keep on going. We started to keep the things our hand, then we incorporated things on us, and now we are creating that inbuilt system within us. So this is exactly the development. Now we are just giving an artificial intelligence like space to create a certain areas within our human intelligence that you just incorporate to increase our agile. So now exactly if you see here, we developed AI and then now we are using this AI to develop agile. This is exactly happening now. So this is a like a very interesting thing. Like first of all, does my AI work? If you see this one, you find out that something is just not going good here. What may be the reason? That like if you see that objective for what this particular game has been just decided and this particular robots has been created, that's not performing so well. So there is something missing out. So one has to look into that. For what aspect particular AI has been developed, for what particular aspect this AI has been created, whether it is just going to fulfill the objective or not. So, like, if we are having a large number of the references and large number of the domain areas is there, so AI is suitable for area, but it has a boundaries. So we have to be much careful about that where we are going to deploy it, whether we are just having a related attributes or not. If all those attributes are exactly working on that, that all those attributes are helping to us, and then we should find it out that exactly this my AI is going to work within that particular certain domain areas. This is more important. So if you see here, like in this section, so like it must have a certain line of reference. If you see like one simulation, the reference is there, and we are trying to find out the humanoid run. So whether this humanoid run is working nicely or not, that has a matter of discussion. So if you don't have a reference line, you don't have a boundaries, you don't have a certain domain of references, then definitely the second situation will be appearing. After some time, your AI will be disrupting and definitely doing its own dance. So, it's more important that you should have a proper reference line while you are just working, while you are just creating, and while you are just developing your this one. So that's exactly called as a reference. So just taken a simple type of example, like how we are just going to create. If suppose you have a simple home automation system and the one is just entering inside a home. So what kind of an attribute you're looking for? First of all, whether you're looking only for the security, just only to check whether a person is entering in your home is definitely a known one or unknown one. So the one aspect is the security. Second aspect you're looking for whether it might be a only a and what kind of a attribute you are just going to incorporate within your system. That's more important. So every time you have to just put your priorities first for what particular factor you're going to work with that. Then after you just associate remaining peripherals and putting an optimized solution with respect. This is exactly nothing but a trade-off. So this trade-off is going to work, then your simulation, then the kind of a reference line, then your exactly the AI which is being created will be working nicely. So this is basically an important part. So if we have a line of reference, then exactly we would be able to create a great model. And that model is going to work in a way for what we are looking for. Look at this one. It's a very, very wonderful example of read, learn, and action. If you see this one, like every time this particular board is system to create an action. And if you see this lag behind, it's just lag behind this one. And this is just finding out whether exactly, if you see here, it is just finding out an object and detecting it to what exactly is need to be pushed up and how much this lag should be lifted up. And so that it is not just disrupting its own pathway. It is exactly capable to learn, it is exactly capable to read, and it is implementing. So this is not totally depending, because if you see here, the distances may be the different one, the height may be different one, and it need to find out that object detection, whether it has a certain kind of a distance or the reference line what you have just created, whether it is executing and fulfilling properly or not. This is exactly the one aspect. So important part, when you are working to make your system smart, when you're working to make your system like reading it properly in the learning and the action part, we are just going to work with that. So it has a certain limit and a domain set where it can take its own decision on the basis of the learning. And this is exactly a nowadays technology called as basically. So the machine learning and the deep learning, that will be just taken up later. But this is exactly a part what we are just working upon. So before going to just make a AI smart, one has to find out, because making a bot is not making a like a artificial intelligence system. Artificial intelligence system is there for what particular objective and the domain it is being created. It definitely has an attribute to complete and fulfill that attribute when it is to be tested. So if we go here, finding out this artificial intelligence, machine learning, and the deep learning. Nowadays, these are the really the good keywords. So if you see that in the air, we find out that artificial intelligence, machine learning, and the deep learning are just going to work with this one. If you see here, the artificial intelligence is nothing but just only an application itself, just only an application. The application has been created through the machine learning or the deep learning. That exactly we are going to work with that. So on the basis of this machine learning, on the basis of this deep learning, the particular application, the particular feature has been created which make your device artificially intelligent. So exactly we have to work with the terminology, either with the machine learning or with the deep learning. So let's try to understand what exactly this artificial intelligence, machine learning, and the deep learning. If you see here, so making intelligent machine and program. That's it. It means it is completely application based aspect. So it is not a new concept. From the early 50s, it has been started that people had been working on that and making the things smart. If suppose there's a room, and the room you have a certain sensor, and that sensor is just telling you that now it is 25 degrees Celsius, it is 14 degrees Celsius, wear your coat and wear your sweater. This is making a system artificially intelligent. This is only one application. So this is exactly not a big requirement and a big deal where this artificial intelligence system is just having a large number of aspects. Keeping only one aspect is definitely making your system artificial intelligence, because you are having only the work related with the temperature sensing and making you able. Because if suppose somebody is here and like in the home you have a kid, and there you are just putting a certain kind of a sensor and you want to make your kid warm, and that's why you're just putting you that particular sensor or device at your home, which is telling if this temperature goes below 20 degrees Celsius or 15 degrees Celsius, then you say just put on your sweater, and it is going above 20 degree or 15 degrees Celsius, taking your threshold values. You're saying no need of wearing sweater. So this is only the one aspect, and you're just making your system smart because it is completely fulfilling your objective. This is an application. Now looking for the machine learning. This machine learning comes like making an ability without explicitly program. Like once you have just given a certain threshold value, so that system is working at artificially intelligent. But somewhat you are looking where the situation may be different, where the different kind of attributes and the aspects may come up, then what the machine has to do at that situation, when the machine has an ability to learn from its environment and finally to make it again trained to work for that, that is exactly machine learning. So if we go for more deeper, like if suppose you have just given a sensing of the 15 degrees Celsius temperature, and you're just given a sensing somewhat related like 20 degrees Celsius, it's a one aspect in making your device smart. But if suppose if in within the 15 degrees Celsius temperature, like it might be possible there is a great sunshine, temperature is definitely giving a sensing and there's a sunshine, and a certain window is there from the sunshine is coming at your home, and even the temperature is around the 15 degrees Celsius, then there might not be a need of just wearing a sweater. So under this situation, then there is a requirement of learning environment. So environment has been changed. So you need to put more attribute in that. As such kind of attribute requires more knowledge, more learning, and then adequate action to make your device more. This is exactly. Working with the deep learning is basically deep neural network. So most of the time, it question comes like, what is the difference between machine learning and the deep learning? In all, if we talk about this is machine learning and the deep learning is just only depending upon the thing of preciseness. That how much you are precise about your extraction of the features, how much precise about your extraction and making it learning and training your set. So let's begin with this because very important. Like somebody is working in the machine learning areas and somebody is working in the deep learning areas, and always we have a confusion that what exactly the meaning of this machine learning and the meaning of this deep learning, where to work and what to work. I think it has a great confusion. So first of all, as I already said to you in the session, that first of all find out your objective. What is your objective? If this particular objective is only depending upon a big kind of a block and classification of the features, then it decides whether it is a machine learning, whether it is a deep learning. So let's see, and finding out on the basis of this attribute, that attributes are going to help you that whether you just have a deep learning sense of understanding and whether you're just working with the machine learning itself. It's just only a basic difference of the algorithms that we are going to create. So let's see first human intervention. Where the machine learning system, human needs to identify hand code and applied feature based on the data type, like examples, pixels value, shape, orientation. Just taking a simple example of a pattern recognition. In the pattern recognition, if you're finding out like whether it is a square, whether it is a triangle, whether it is a simply a rectangle, like this is. So what one has to do? One has to find out all those particular codes, identifications. So when you're just picking up this broad level identification and getting all these kind of codes, and putting it into at a set of the data set, then you are just going to create a basically a machine learning. While a deep learning flight system tries to learn those features without additional human intervention. So itself, when you're working with the deep learning, because it is completely based on artificial neural networks, so it makes sense itself. You do not need to give that segmented data and providing the information to the system through a program, through a code. Instead of that, it is to find out. It is finding out whether this particular line is going straight and having a curve. Then, if it is having a curve, that it might have a possibility of having a circle. Then in section, it is looking for whether all kind of lines are equal. Then it might have a square, and whether it has equal, but in the halfway and another way, it might be a different one. Then it might be a rectangle. Or checking out whether it has some curve or slanted line. So deep learning itself is finding out its features without any human intervention and just only getting a certain information. Obviously, while we are working with the hardware system, exactly. So when you have a large number of the things working with itself and making your machine to think more, exactly, it requires a powerful processor. So this is exactly the second difference, key difference. First is the human intervention you must have. The second is the hardware. Third is time, obviously. Because you're working on a deep set or working on a broad level set. So deep set is definitely taking a much time, and sometimes it may take a couple of weeks to learn. Weeks to learn a particular features. It requires a multiple iterations, multiple epochs to learn about the aspect. And then coming up on the approaches, what kind of approaches you are going? Algorithms, that's a part. So if suppose we go for machine learning, in the machine learning, there is a definitely algorithm used which put the things in a part and finding out the different areas and the domains out there and then combining all these parts. But the deep learning is putting all the system and scenario in the one part. As simple as I already told to you, like if suppose you are going to find out the difference and going to distinguish whether it is a triangle, square, rectangle, or a circle. So it is not we are going to give a certain pattern to into it. Instead of that, we are just going to just only giving a feature related with the line, then its orientation, then its inclination, and its curvature effects. That's all is to be executed within deep learning. So, if suppose in approach, if you go for this example is showing that if suppose in a car parking we have a number plates. So if you go for the machine learning, so you machine learning, you have basically two aspects, whether you have a car and the detection of the object and recognition. First, you are going to detect and then recognizing it. So two different sections. In machine learning, you have basically two different sections. One is part of detection and the second part is recognition. While in the deep learning program, when you go for that, you will find out that only on you're just giving images of the system, and this is the deep learning system itself will be working whether it has a number plate or not, or if it has a what kind of a plate it has, whether it is there in the parking lot or not. So as a whole system, it is being given as an input. This is exactly the so most important. This is an application that how you're just going to make your system smart with the attributes. You need to do only this simple kind of a programming and algorithm in the small parts. But when you have a kind of a certain things, if you see here, within the two diagram, if suppose one simulated game is here, so this has only object detection to find out whether the ball is there and is looking only for. So this is working on a simple attribute and a domain to find out that particular shape of the circle. On the basis of that circle, the action has been taken, and definitely the racket is working along with that in the direction. But in the case of the self-driving car, not only we are looking for only one object, which is the car itself. We are looking for the track, we are looking for the building, we are looking for the trees, and finding out the space. So many attributes are being added, and as a system of whole, only the one aspect is given that particular that this car has to run on the way where there is no one. So among finding out the no one and number of the things are there, so there is a big and huge difference. This has to be taken up very carefully, and that requires a very large data set. All in all, if suppose I conclude this particular key attribute between the machine learning and the deep learning, one should understand that the machine learning can be designed for the single kind of an attribute, single kind of a feature that we are going to create within a system or to multiple. But the deep learning requires every single attribute with a large set of the data values for every possible aspect within the system. That's the more important. And that's why the deep learning have a more complexity as compared to the machine. If you see here, like again, taking with the help of one example, we have an input in the both the cases, one in the case of the machine learning and second the case of the deep learning. If we see here in the machine learning, first of all, we are putting this particular car input, just creating out the feature extraction. How we are going to identify the feature extraction? Like if suppose this it is a very simple as we were it to identify the things. Like when we started learning the things, when we were just growing up and try to find out and identifying the things, and this was exactly the machine learning. Like if suppose we have a car, so we are first of all we are looking to find out whether car has a certain kind of a shape. First of all, we look for the shape. It's a big kind of a shape, but the bus has also the same shape. So how do we identify? No, there should be a shape. The shape definitely must be too not large. Again, what we see, then we have a certain kind of a structure of the car. That yeah, it has a shape, but it has a different kind of a curvatures within it. And somebody is there, two doors are there, but in the bus it's not looks like that. So we try to find out the features and we extract the features. And that features may be depending upon the individual's learning. That whether it is identifying from the structure of the car, whether it is identifying from the door of the car, whether it is identifying like steering, whether it is identifying like the tire sizes. So this is exactly the first part. So if suppose we have a certain system which is going to design and try to find out the number of the vehicles on road, and we only need like one, which has to be a car only, then exactly it needs to find out certain feature extractions so that it can make it classified. And on the basis of this, we go for classification. And then finally, once we classify them, creating a certain kind of a network and the algorithms, then we can decide whether it is a car or not a car. So this classification, if suppose we are finding out number of features, whether it is a tire size, whether it is finding the glass size, whether it is finding the bonnet curvature, whether it is finding the whole structure size. So if we suppose finding out all these segregated sections, and under these segregated sections, and we classify them, if suppose all those features are extracted, the image processing and assembling them and finding out all the features are true, then we can say it is a car. If one of the feature is not true, then we can say something else. It might be like a bicycle, might be a motorcycle, might be a bus itself. In the deep learning, so we are not putting this to segmentation. As far as the algorithm is concerned, we are not just doing it in a two different sections. We are itself giving only the car as an input. What exactly the car has given as a part of input image. So this input image is being put within the deep learning system, and when it is just being put, this particular car is going to be extracted within the system at the different aspects of the features, and each and every feature is being classified, verified, and on the basis of that, it is being decided whether it is a car or not a car. This is exactly a huge difference while the algorithm is concerned. So if suppose somebody is looking to create this machine learning algorithm and somebody is looking to deep learning algorithm, the deep learning algorithm is working within the neural system, and it is just finding out the feature extraction and the classification within a common algorithm programming. And here we have to first of all have to give this classification a different kind of feature extraction as an input. This is exactly the part. So like moreover surveys were there, and among all these surveys it is basically find out and absolutely found true that all of them are not so far different from each other, but exactly a subset of each other. So deep learning, machine learning, and the artificial intelligence, 1, 2, and 3, taking all these are not different aspects. All of them are the subset of each other. If someone is just working and doing, creating some sort of attribute and making machine to learn the things, or making the system smart and creating it artificially intelligent. And somebody is working to create with the deep learning is definitely creating a machine to learn with more preciseness, creating a machine learn without an explicit program, creating a machine to learn without a feature in. So this is what the deep learning, but actually in what? We are just making a machine to learn. This is important. And ultimately, the deep learning, machine learning is making your device artificially intelligent. So, like one more thing is here, if you see the cat and the dog, yeah, exactly. We are just going to work with the different layers and finding out all those features on the basis of the pixels, on the basis of sections, design aspects, like because each and every feature, like we are also watching and we are easily capable to identify whether it is a cat or a dog. So all these level things require the feature extraction on the basis of all multiple stage. It would be able to whether we have a cat or whether we have a. But somewhat we go for like the machine learning, as I already told to you in this case, that machine learning is somewhat having a certain limitation because while we are just going to match the features, it might be possible on the basis of that some of the features may be matched with each other. If you go back and see that, like here in this case, it might be possible that having a face of a dog and having a face of a cat might have some sort of a common feature. And on that basis, it might be possible that image classification comes like that, that it might have a 82% cat and 15% dog aspects, and so many in the hat and the mug just look like a shape. So this might be possible that it looks like a simple a mug or 2% looks like a hat also, because it has a similarity index and it is limiting up. So what is this limitation? This limitation is the preciseness and the precision of the data set. If we are further capable to break up those data which has identifications domain and identification limits under them, we can say that this particular aspect is quite different, because if we find some similarity in the cat, dog, cat, and mug, if we find some similarity is in that, that it means here in this case, we have a certain level of classification which has not been done within the machine learning tool. Then exactly is now important to explore it more. And here, this sense is called as a deep learning. So this is exactly the limitation of the machine learning. This is as simple as you are training your own neurons. It's very, very easy and very, very simple kind of a case that you have done something, you have learned something, but you forgot. And once you forgot it, then definitely it's creating a mismatch. And that thing which is in your mind, it means your neurons were not trained deeply in that sense. And that's why you are just having some mismatch identifications. That whether, if suppose you have seen someone 10 years and 15 years back, and then today you are just recognizing and finding that person is somewhat known to you, but exactly the name you are not able to recognize. And somewhat you are just recognizing him by the different name. So this is the another aspect we have here. So this happens because your neurons were not trained explicitly. That's why here it requires that limitations gives you the need of more data and more detailed understanding of the particular feature and more extraction of the feature. That's why we have a limitation of this. So where we find this machine learning, where it is not working, and we go for this deep learning sense, and you see here that what exact preciseness is here. We have a complete background. It's very same identification of this horse and making it a zebra. Is exactly a very, very wonderful example of simulation example of the deep learning. That how it is being created and how it is going to be designed. That's an important part. If you see here in this case, this is just going to give a proper absolute precise identification of the feature of this particular image, even though we have certain things which has a correlations with respect to this particular and with respect to the background and the foreground, where we have the wires, where we have the grass, where we have like horse hairs, and the grass may have some similarity in taxes. But the expression is so much precise that at every possible point, that whatever the employment we wish to have, that is properly deployed, and that horse has been created into the zebra. That's exactly the part of deep learning solution. So this is exactly a great difference. This is exactly the great working sense, and how it is exactly possible. It is a matter of a great work and a great research where we are working upon. Like, it completely depends upon, like, if you're making, we have a great sense of working with the artificial intelligence, but it exactly depends upon what exactly your objective. If this objective is somewhat related only identification of a horse and putting a mark on a horse, it's not a big deal. But creation of a such kind of a zebra lines on the horse is exactly making your objective more precise and more complex. Then this machine learning limitation comes up, and during that part, the deep learning sense will give a better solution. This is exactly the part. So we have a certain solution related with that, and we have a learning, prediction, and creating an AI. That's an important part. So with the help of one simple example, we can attempt to cover how much, if suppose for a 10-second, how much distance we are going to cover. It's a 36, for an example. Suppose we are increasing speed at twice, and how much distance we are going to cover. This is exactly a regression. So if we see here in this case, we have a certain line, which line is telling you if suppose you are changing your speed, then exactly you are just having a change in your distance. And this is just only a relationship between kind of a data set. And this data set can easily be adjusted in the height, weight, and other factors of a person, so that find out the predicted age, at what will be the age, or how many long years he is going to live. That kind of an analysis can be done. It can easily be done if suppose the past analysis like that, and whether the price is going to be rise or fall. This can also be possible here. So if you see here in this case, we have a certain line which has a positive slope. And you find out that y equals to mx plus the distance traveled in a fixed time interval. X is basically taken as a speed, and we have a certain. So if suppose we, or where it is going to start, that's important. Where you have just taken a reference. Because everything is not being started with like having a data set of the 0, 0. If no one is there, then definitely no. It might be possible. If no one is there, then it's still definitely it has certain output. So it might be possible. So this is basically called as an intercept from where your system is going to start. And what was your state? Where it was actually when it was about to start. So if you see here, so you need to just create a certain line where all data set values going to make a system satisfied. And on the basis of that, you would be able to create most possible values of a predictive feature. So now, taking another reference, distance is a constant. So if you are increasing the speed, obviously you are just having a less time, and definitely the time is decreasing. In this case, if you see, this line looks like this, because with respect to increase in speed, you have a less time. Time is decreasing continuously. So this shows you that speed and time will have a negative slope, but it has a definitely again a line. And from where again it is started, you can easily get from it y equals to mx plus c relation. Now just take a simple linear regression data set. If suppose you have two values, one is x and the y, it may be related with anything, whether it is related with the gender and age, whether it is related with the person's attitude with respect to its brain size. It means everywhere, wherever you are looking for, wherever you kind of a data set you have, whether the person is coming to you depending upon the images you have, the pixel values. So it means when you have a data set of such kind of a relationship, x and y relationship is there, you're going to create this one. you may have a certain kind of a points. Yes, when this x is 1, then you have a certain y3, 2, and so on. So you can easily find out its values. The mean values are there, and the mean value of x and the mean value of the y. This mean value, if you get, this is a 3, this you get the mean value of the y output. This is taken as the 2.8, and this is a point created. Extending it more, so creating this y equals to mx plus c. Now we need to find out its slope and exactly looking to find out the line. So here, this is a simple mathematics you have done in so many times in statistics that we are going to use in the machine learning is completely a mathematical tool. We have a target to find out the slope m. So if you have the data x, y, you have already got the value of mean, you have an x minus I, it means what deviation you are just getting. Then you're just getting a deviation in the output, getting a squares to find out the mean square values. Among them, using this simple formula, one can easily get the slope, which is making a mean marginal space. Mean marginal, it means more mean marginal, it means less far from each and every data aspect. Creating this y equals to mx plus c and finding out the slope m, and you would be able to get the values here. So see, getting all this one and simplifying, you would be able to get the slope as 0.2, getting all these values from this one. Just taking a simple example, you can easily create this your own table here, and you can find out the value of the slope m, and you just got this value of 0.2. Simplifying this 0.2 on the basis of the values you have chosen, that's the main values, 0.8 and 3, and finding out the intercept. Intercept is just giving a value where actually at the rest your system was, where you're just going to begin, because it is important. It's really important. It's really precious, because if you don't have that reference, then surely you won't be able to get the exact model of the learner. So on the basis of that, you have just created, you will see here this red line, you have just created a certain regression line. And that regression line, if you see, we have a data, this one, and we have the data. And this regression line is simply indicating you that each and every data has minimal difference error with respect to this. So this is basically an error point. This is one minimum error. We are just going to create this one. So this is the reference line. And whenever we are just putting the data on this, so this is giving an approach to you to get the next value, which exactly follows the same track on which the previous data was. It may be taken up the different kind of a different cases. Like same is there in the case of the blind stick. I've just taken the example. If you have just collected as per as the distances are there for the different distances, you have just already collected a data set. But suppose you have a moving object. So moving object is definitely changing in distance because you're having an ultrasonic sensor. And this ultrasonic sensor is returning you certain frequency back in a period of time, but that motion will be taken by the vehicle or the moving object is there. At that situation, under this condition, it might be possible that this particular error will come. So that's why this regression line has been created, and this regression line shows you that already a preset data values, the previous data values existing on this particular regression line, and the next value can easily be predicted. Now the task is there to reduce this error. How we can reduce this error? That's the most important one. And when we are just going to create this error reduction process, this is going to make your model more fit. That exactly we talked about in the previous case, that if you see here, going back to this one, this is exactly the issue. You have just created a certain regression line, and that regression line is helping you to guide your certain predicted outputs. But how much exactly it is being fit, that depends upon that how much error you have reduced, how you just minimize your error. So the second goal, the first goal is that you just create a regression line. And the second goal is here to create a certain kind of a techniques to reduce all those errors. So reduction of error has so many ways by which you can easily reduce. So like in this section, we are not just talking more about on this reduction error. So many absolute error root mean square methods are there. Many mathematical aspects are there on the basis of that can be created. Second is here, like we have a decision tree. Second way of creating a machine learning, the decision tree can easily be created if you see here. So if suppose take just first figure which shows you, if suppose the age is less than 30, yes, you can eat pizza. Yes, you are unfit. Eat pizza? No, you are fit. If suppose your age is not less than 30, you're definitely greater than 30. Are you exercising? No, you are unfit. Are you exercising? Yes, you are fit. So this is just only a decision tree. It means we are classifying the data into the different category, and we are segregating the data into the form of some clusters. And then we are just taking a decision on the basis of that. This is another way to create your machine to learn. In second case, if you see here, we have a certain homeowner. Yes, no, yeah, second status there. So we have a certain field like homeowner, marital status, annual income, and credit ranking. So all of these is a node is decided on the basis of a tree. Like homeowner, yes, it's a good one. If you are not a homeowner, आपके पास घर नहीं है, you are not having this one, then there's no. Whether you are marital status, married, then definitely at least you have a good thing. You are married. You are single, divorced. Oh no, that's again a bad thing. If you have an annual income like greater than 80K, then fine. You're not a homeowner, but you are not a married, but you have a good income, at least you are at a satisfactory level. Suppose you are not a homeowner, you're not married one. Oh, and again you have a certain income which is less than 80K, definitely you are in a bad position. Something is like that. It's just only taking a decision. And in similar way, we have just created such kind of algorithms in our system to make a particular system. That kind of algorithms are generally used while you are just having a access on the policy bazaar and somewhere is there, or just looking for the loan and finding out your civil. So they have all such kind of an aspect in creating a such kind of a decision tree. And on the basis of that decision tree, they finally give you an offer whether you are just going to purchase a car, whether you're just going to purchase a home loan, or something else is being offered. And then this particular data is spreaded all over so that you just keep receiving so many calls related to that. So this is exactly a way of create a decision, and that particular thing is directly related with what? That is related with the system itself. So new human intervention is working upon that. This classification is done on the basis of itself algorithm which is being designed for it. Similarly, another kind of a decision tree, it is depending upon one simple example we have just taken here. Whether to play golf or not to play golf. If suppose you're going to play a golf, again it depends on so many things. It depends upon outlook. It depends upon temperature. It depends upon humidity. It depends upon wind. Whether outlook is rainy, overcast, it's sunny, it depends upon things. It depends upon a temperature itself, whether it is a hot, cold, mild, and so many. Humidity is high. It is a windy or not. So all these factors are going to make a decision on the basis of that. Suppose somebody has just created a certain decision tree. Humidity normal, then play golf. Humidity high, then go for the outlook. Check this one. Sunny, then don't play. Overcast, then play. Rainy, don't play. So does it simply a decision tree has been taken? So it might be possible that a decision tree which is being taken, if it is being made wrong, then obviously the output will not come through. So if you see, playing a golf outside is only depending upon the first factor, which is the humidity. Depending upon the humidity is high or normal or low, one can take is a decision whether it is rainy outside. So if you see the flaws here, it is saying yes, humidity is normal, you can play. If suppose it is rainy, how one can play? So one has to check whether the all conditions, all things are satisfied or not. This is important. So decision tree is based on basically the two things, which is basically the entropy and the information gain. Entropy is more important. It is somewhat related with the randomness So how much random your data, how much impure is data set is there. And the second is what the information gain. So this information gain is totally deciding that what exactly the possibility of the information you are receiving from your decision. So one has to work with the two different mathematical tools, is the entropy and the information gain. On the basis of that, once you have calculated this one, then one should go for the decision tree. One need to find out this decision tree and then check it out. So first of all, go for the outlook. If it is sunny, overcast, or rainy. So if it is rainy, you can't play, so don't play. If suppose it is overcast, you can play. If it is sunny, you have to check whether it is a windy or it's not a windy. That simply give an output whether to play or not to play. So let's take a condition. Now machine is going to make a decision. You have just given a two input to your machine that it's a sunny and windy. So sunny and the windy. So this your decision tree is going to help you and it's going to give a decision. Don't play because it's a sunny and the windy. So it is just giving an output and giving this decision. Now taking this one. The third tool, which is more important, is a support vector machine. The support vector machine is just putting up some flaws within the where the decision is creating a problem. Like you don't have so much clustered data where the decision can be taken up. Under this situation, under such kind of effects, then the support vector machine will. It is somewhat related with the regression, but helping help from the vector from the classified data. How it is going to work? If you see here, the different kind of the data has been classified on the basis of certain kind of a plane, which is called as a reference line. That reference line is taken up here. So this support vector machine can easily be taken from this example, simply itself. So let's take an example. We have a certain weight and height data. And on the basis of that weight and height, one wish to find out that whether it is a male or females. So checking it out, whether it is a male or a female, we need to create a classification of data. And somebody has a certain new data point. The important part, let's create a line. So we have just created a regression line, a reference line. That's a very simple. And the reference line tells us that this particular one is basically a male. But this kind of a line can also be created. This tells us that it is a basically female. So when male and the female categorization is there, when male and female categorization comes up, then it might be possible that it is giving a false output to you and that decision is not very adequate. What can be done? So under this situation, a reference plane has been created on the basis of a support factor. So the maximum possible margin has to be found out. Suppose you have just created a certain line, you need to find out the certain margin. And that margin is totally depending upon the most possible near value related with this reference line. Like the female has a certain height and the weight, which is existing up here. And similarly, the male has a certain height and weight, which is existing here. And these two are called as a support vector. And on the basis of these two support vector, a reference mean margin line has been created. And now, if suppose a new data set will come up, on the basis of that, this margin line will help to make you comfortable to make a decision whether it is a male or female. So, well, this is like a support vector machine. So if I talk about among three, so we have first of all regression. Second, we have talking about the under the situation where we are working upon like the support vector machine is there. And we also work upon the decision tree. So these three sections are helping you to create your machine learning. What to use where? That's important. So it is totally dependent upon the preciseness and the error of the data. That how much your data is precise and what error can be adjusted. So taking an example, like a simple objective, simple type of where the marginal gaps are not so much effective and so much important for you, there you can just have your linear regression method, where you have a very classified data, different segmentation of data like decision tree that we have already talked about the security system. Under those system, you can easily take like a decision where the where we have just only work upon like a situation where you have an uncle, you have an aunt coming on your door and finding out the details, and like most important part. And similarly, checking out whether the person should enter or not. That is a classified data. The decision can be taken. First of all, check whether it is an old person. Now check old person is uncle or maternal uncle. So it might be possible you are allowing your uncle, not allowing you maternal uncle. So first of all, it check the old age person, then check maternal uncle. Yes, whether it is your uncle, no. So decision has been taken on the basis of the decision tree. The support vector, when you have a very precise values, and during that, it might be possible that you need to go for identification of this. So this is all about basically a three terminology and the domain area. Like machine learning is too vast area. So thank you here. And so many algorithms, so many things are there. But like the stuff to just cover all of them in a small span of time. So like most of the part like here. So I'm just covering up. So in conclusion, in like a session, I wish to say that like it's very simple. It's very easy. You can create your own model. Preciseness of model will be decided on the basis of your objective, and objective can be executed on the basis of your data set. And on the basis of your data set, you create an algorithm, and that algorithm may be based on your support vector machine, maybe depending upon your decision tree, maybe depending upon your regression. So here the session is open. If somebody has any doubt, any question, may ask me. Thank you. And then in the next session, we will talk about more about the how we can work upon with the writing algorithms and programming with the help of Python. Thank you. Exactly, sir. Exactly. To agree with you. So we're gonna try. Also, I'm just typing my YouTube link also, and as well as a LinkedIn. So if anybody wish to be connected up there easily. Yeah, yeah. 30 hours tutorial is there. Yeah. Thank you. Yeah, exactly. Nowadays so much learning is there, so everybody is definitely asked so many questions. So, well, like this might be possible. You do not have questions right now, but invitations are open. Those are working in the area of the machine learning and artificial intelligence. They can easily write up to me, and definitely we can collaborate. Common thinking about that. We can just collaborate to work upon that. So, my invitation is open to all. Thank you, sir. Thank you, sir. Thank you.